Hello and welcome back to Higher Maths Differentiation. We're looking at some more complex examples here. We're going to look at example 3 and example 4 in this video. So a function f is defined by f of x equals x over 5, or we could think of that as 1/5 of x plus 1 over x squared. Find f dashed of x, so find the derivative of f of x. So f of x equals x over 5, which is in a format we can differentiate. Or we could think of that as 1/5 multiplied by x, remember, because dividing by 5 or finding a fifth of something is the same thing. Plus 1 over x squared, well, we cannot differentiate that at the moment, so we must bring this up and make it x to the power -2. Now it is in a suitable format for differentiation. So on this line, I would write f dashed of x. Now, that is reminding me about something that people sometimes do. Sometimes the occasional pupil will differentiate one term on one line, but leave another term not differentiated. So you need to differentiate all of the terms on your same line of working. So I would not want to see 1/5 plus x to the -2 together here, for example, because that doesn't make sense. So please don't do that if you're thinking about doing them one term at a time. So get it into a suitable format for differentiation, which we've done. And then differentiate x, we get 1, so that become 1/5, because it's x divided by 5. Or if we're thinking of it as 1/5 multiplied by x, that would just differentiate to 1/5. And the second term here, power to the front, so it'll be 1/5 minus 2, drop the power by 1, 1/5 minus 2 x to the power -3. And again, I started off the question in the form 1 over x squared, so I had a positive index, a positive power. So I'd rewrite that as 1/5 minus 2 over x cubed. Question 4. Right, question 4 is an exam type question, that isn't always answered that well. And that is looking at the SQA's examiner's report, so that is over the whole of Scotland. So the reason why it is not always answered that well is that pupils confuse what is happening here, 1 over x squared going to x to the -2, which is totally correct, with thinking they can do that straight away here. Okay, so what we need to do first here, we need to break the fraction up into two separate fractions. So it'll be x to the 4 over 5x minus 3x squared over 5x. Okay, because what happens, sometimes pupils bring this term up and they only multiply the last term by the x to the -1 and forget to multiply the first term by the x to the -1. So the more that method is an error-prone method. This method, if you remember to do it, is an error-proof method, so you're not going to make the little mistakes that will drop your marks. So split your fraction up into two separate fractions. Use our national 5 indices rules for dividing. So x to the 4 divided by x would be x to the 4 minus 1, which is x cubed, so we'd have x cubed over 5. Here, x squared divided by x would be x to the 2 minus 1, because when we're dividing powers, we can just subtract them. So we'd have x cubed over 5 minus 3x over 5. And again, we've not differentiated yet, so I'm still saying d by dx of. And then at this point, we differentiate. So power to the front, 3x squared divided by 5 minus, well, if we differentiate 3x, we'll just get 3. So minus 3 divided by 5, minus 3/5. So remember to do that, guys. If you have a fraction, split it up into separate fractions. So if you have a fraction with more than one term on the numerator, I should say, split it up into separate fractions. And we've got example 5 and 6, which are even more complex. I will do separate videos for examples 5 and 6.